y at 3. What's happening there? Is there a cusp? No. Is there a point of inflection? No. Didn't change concavity, right? Concave down, concave down. Where would I have a vertical tangent line? We wouldn't? We would never have a vertical tangent line. So, is this ever not differentiable? No. So then we could say what? F of x is differentiable at all, okay, you want to say at all real numbers?
Or what would be the other thing?
I was just going to say at all x values. Yeah? Is that cool? Could we say at all real numbers? That would also be good. Could we say f of x is always differentiable? Yeah? Those are all acceptable answers. Cool? And the last one, acabar con una brocha de oro. Okay, as they say.
Yeah.
So sketch the graph of f of x is equal to 1 over x minus 3 by visual inspection to determine the points where it is not differentiable. Okay, so let's look at this. What kind of a function is it? Starts with an R. Rational, right? Okay, so rational functions sometimes have what? Holes or vertical asymptotes or horizontal asymptotes, right? So can you tell me if it has any of those three things? It has a vertical asymptote. How do I find those? Denominator equal to 0. Okay, so what's the vertical asymptote for this guy? X equals 3. Does it have a horizontal asymptote? Is it Bobo? Remember the 3 killer clowns? Compare the degree. So what's the degree of the top? 0 because there's no variable. What's the degree of the bottom? 1. So it's bigger on bottom. So 0, right? So bigger on bottom. Right? So it's y equals 0. Right? Because remember, Bobo. You can't put that. I'm just putting it for right now so you can remember.
So we don't have to say bigger on the bottom?
You don't have to say anything, you just have to label it, right? And you don't even have to do that, we're just doing that so we can graph it. This is what you need to think in order to graph it.
On the AP test.
Because Bobo, some people, they put horizontal asymptote, but they don't even put this, they just put Bobo. No! That's not the horizontal asymptote, that's something to help you remember what it is. You remember it from pre-com? People would put like, oh, Betsy. Alright, anyways, so let's draw this one. We got an asymptote right here at 0. And we got another one at what? 3. And the graph of this is just like the rational function, right? Remember that butterfly graph? Okay, so it should look exactly like this. Should come down. It's going to hug the asymptotes, you know? You gotta hug those asymptotes. Alright, anyways. So, looking at this graph, where would you say it is not differentiable at? So, you're going to say f of x is not differentiable at x equals 3. We have to say why. You can't just tell me that it ain't there. You gotta give me that y, girl. What's the y in this case? Because f prime of x is undefined? Nope. Because there's a vertical asymptote, so what does that mean? It's not continuous, right? That was one of the 3 things, right?
Yeah.
Okay? So here we would say it's not differentiable at x equals 3 because f of x is not continuous at x equals 3. Do you understand? So the first thing you should always check for before you look for anything regarding not differentiability is continuity. If there's somewhere where it's not continuous, boom! boom, automatically that's where it's not gonna be differentiable. Okay? So to be differentiable, it first has to be continuous. But because it's continuous doesn't mean that it is differentiable. Do you understand? Like, it's kind of like, I need you, but you really don't need me. Yeah?
And if it's different,
It's kind of like your parents, right? You need them, but they really don't need you, right? Oops. Okay? Got it? Alright, so we're going to stop there. And I'm going to let you leave with that thought. And we'll continue tomorrow, okay? You don't love me, mommy.
I'm gonna show you anytime.
I don't know if they like their tax cuts for their dependency.
Therefore, they do need a